Hello, dear friends. Now, I hope you are happy and safe. Okay. So here we will discuss. Lastly, we discussed regarding our basics of matter. In that, we saw physical classification and chemical classification of matter. Okay. So today we are going to discuss characteristics particles of matter. So already according to kinetic theory, okay, according to kinetic theory of matter, the particles of matter have the following four characteristics. Okay, so in that first, the particles of matter are very small. So as like previous say the potassium permanganate example, so I will show with one slide. See here, potassium permanganate. So as like this means how much small of that potassium permanganate crystal. Okay, so say you can observe here. First is if you dissolve in a small amount, means if you dissolve one crystal in water, so you will get dark color. Okay, again if you further dilute with water, then see how colors are faded. Okay, so these are what here the particles of matter are very small. Okay, now as you know why these are small, because the matter is composed of small particles. Okay, now if you saw the example of small crystals of blue vitriol, also see here blue vitriol, that is what, copper sulfate. Okay, so blue vitriol copper sulfate, if it dissolve in water, it begins to become a blue colored solution whole, and slowly the size of the crystal becomes smaller and smaller. Okay, the crystal has divided itself into number of smaller particles and ultimately dissolve in water. So these experiments also suggest that the matter is composed of small particles. So I will show here how copper sulfate, yes, say here in copper sulfate, how if it dissolve in water, first that small, first suppose big crystal, then ultimately it will dissolve in water and become small and small, so it can dissolve easily in water. Okay, so see here, whatever our next example we can observe here, the particles of matter have spaces between them. Okay, so as you know, okay, there are say there are present spaces in between the particles of matter. Okay, the size and number of these spaces how it differ from one kind of matter into another. So experiment, suppose if you are considering as a chalk. So as you know, what purpose we are using chalk, used for writing on blackboard. Okay, when you deep into water, some water is absorbed by the chalk, and there are because of why? Because of vacant spaces or pores in the chalk which are occupied by the water. Okay. Now suppose if they are giving in slide experiment number 2 also they gave, if you take a wide mouth test tube and almost half filled with water. Now put a sugar cube in a test tube and mark the water level with a glass marking pencil. Now the sugar cube will dissolve in water and the level of water goes down. Okay, why goes down? Up to a small extent, because there is a vacant space between the particles of water, and this vacant space is occupied by the particles of sugar, and water level goes down. Okay, so like that it is a very much interesting example regarding particles of matter has spaces between them, and the particles of matter are very small. Okay, now see diagrammatically also, they given water level and how it becomes to small extent it will decrease. Okay, you can see with diagrammatically. Now suppose if you are thinking about third, the particles of matter are constantly moving. So constantly moving with the help of what, Brownian motion. So it is the best evidence for the existence and movement of particle in liquid was given by रॉबर्ट ब्राउन. ठीक है. Now Robert Brown, what he done? Robert Brown suspended extremely small, extremely what beta? Yes, small pollen grains in water. On looking through the microscope, so it was found that the pollen grains were moving rapidly throughout water in a very irregular manner. Okay, if you observe through a powerful ultra microscope, then what you will get? You will observe irregular manner of that pollen grains. Okay, see the figure also they gave Brownian motion, see pollen grains, and we are observing invisible moving particles of matter also. Okay, now see the movement of pollen grains on the surface of water can be explained as follows. So see how they explain. Water is made of tiny particles which are moving very fast. So water particles or water molecules themselves are invisible under the microscope because they are very small particles. Okay. Now one more here remarkable statement, if you are observing, if you heat that water, okay, water content of, if you suppose warm that water content, then movement of pollen grains also will increase. Okay, understood? Okay. So these are what regarding your, yes, regarding your Brownian motion, Brownian movement. Now we will observe here some another activities also. Okay. So say if an incense stick is lighted and placed in one corner of room. Okay, yeah, now that it's, as you know, it has a pleasant smell, spreads in the whole room quickly, and it demonstrates that the particles of matter possesses motion. Okay, particles of matter have motion also. Now a burning incense stick produces some gases, vapors having a pleasant smell. Now these particles of gases due to the motion spreads in the entire room, and their presence can be felt by sensing the smell. Okay. Now you see we will diagrammatically also say agarbatti, how if you lighten that agarbatti, then whole room it will occupy. Okay, and a pleasant smell you can smell it. Okay, you can sense it. Understood? See, small b they gave here activity to demonstrate that the kinetic energy of particle increases with increasing temperature. It is very much interesting. If we took two beakers, in one beaker 100 ml of cold water and another beaker there is 100 ml of hot water. Okay, now here what will happen if you add some potassium permanganate to both the beakers? So what will happen? Yes, what will happen beta, whatever in beaker there is a hot water, so it will, whatever potassium permanganate will dissolve rapidly. Okay, and very in cold water it will take a time to dissolve. It will dissolve, no doubt, but it takes a time. Okay. Now from this what was the conclusion? So conclusions here, it is observed that the purple color of potassium permanganate starts spreading, and after some time the entire solution becomes purple. So here from this what we conclude, the rate of mixing faster in case of hot water. Okay, so basically these are whatever our this topic matter in our surrounding. We are observing day by day this all. Okay, means here the rate of intermixing is faster in case of hot water. So this experiment demonstrates that the particles of matter possesses motion, and that the kinetic energy of particles increases with increase in temperature. So it is a very much important, these are statements. Okay. Now see, we can observe one more thing also. Whatever intermixing, these are spontaneous process. Okay, natural process. So this intermixing is possible due to the motion of the particles of matter and also due to the space between them. The intermixing takes place due to the movement of particles of one form into the space between the particles of the other form of matter. Now here, whatever spontaneous intermixing is going on of particles of two different types of matter. Okay, so we call it as a word diffusion, spontaneous intermixing of particles of two different types of matter. It's called as diffusion. So here one more important statement: the rate of diffusion becomes faster with increase in temperature, because at high temperature the particles have more energy, hence they move faster. Okay, so like that it is a very much important thing we discuss here. Beta, you have to remove notes, or you have to solve in text questions. Okay, now see, we will discuss here whatever our next. See, you are observing this, what it is. Yes, it is what, if you put a drop of ink, okay, in a suppose it is what 250 ml beaker, then how it's diffuse. Okay, blue ink, now here what, red ink, diffusion. Okay, if you increase, then rate of diffusion also will increase. Understood? See that example, how chalks are, if it is all in water, they absorb some water, whatever your chalk. Okay, now see how diffusion it will occur. If you drop ink in a water, now it slowly spread entire solution. Now see color completely what, blue only of that particular solution. Okay. Now see here, we can take here as a one more example in question form. As you know, we can get smell of perfume sitting several meters away. Why it is? Yes, why? Because perfumes contains volatile solvent which carries a pleasant smelling vapors. They diffuse into this environment, okay, quite fast and can reach two people sitting in several meters away. So like that, here what we conclude: particles of matters are continuously moving. Okay. Now see, they gave definition also, diffusion. Okay. Now diffusion is what? The process. Now only we saw the process of intermixing of one state of matter to another is called a diffusion. For example, diffusion of sugar in water. Okay. Now they gave examples also here. They give an example of each type of diffusion. Solid in liquid. So solid in liquid we can call it as a what? Sugar in water. Second, gas in liquid. Yes, gas in liquid. Oxygen in water. Now how we can conclude here oxygen in water? So as you know, beta, some amount of dissolved oxygen is present in water. Okay, dissolved oxygen is present in water. Therefore, we can here say gas in liquid. So oxygen in water. So solid in a gas is what? Dust particles in air. We can observe easily dust particles in air. Now see the next, liquid in liquid. Okay, liquid in liquid is what? Milk in water. Okay, and next, gas in a gas. Oxygen in air. So we are observing. Uh, as you know, air is a what? But a mixture of gases into, okay, O2 and another inert gases in very small amount. It will present. Okay, so like that it is very much interesting this topic, but all are theoretical. Okay, you have to read NCRT thoroughly. Okay, and you have to concentrate on whatever these points also. Okay, now see, they gave another also example. A bottle of scent when open in a room, its smell spreads out. Why? Because of diffusion of gas particles. So as soon as the bottle is opened, the same particles come out and get diffuses with air soon and reach from one place to another place. Okay. Now, so what will be the fourth hour? Fourth is what? Characteristics of particles of matter. The particles of matter attract each other. Okay, so see, there are some forces of attraction between the particles of matter which binds them together. In that we can here observe some forces, that is small is cohesive force. Okay, so cohesive force we can observe here, the force of attraction between the particles of some substances is called as cohesive force. The force of attraction between the particles of some substances. And adhesive force, the force of attraction between the particles of different substances. Same substances means cohesive forces, different substances is what? Adhesive forces. Understood? So example here, if you take a piece of chalk, a cube of ice and an iron nail and beat them with a hammer. So what we can observe here, chalk will easily break into smaller pieces. Okay, but more force is required to break a cube of ice, iron nail, so it does not break. So what we conclude from this, force of attraction is quite weak in between the chalk particles. Force of attraction between the particles of ice cube is bit stronger, but the force of attraction between the particles of iron is very strong. Okay, means cohesive forces, same substances. Okay, and between the particles of different substances, adhesive forces. Okay, now we will concentrate on what are the rigid and what is rigid and fluid. What is the difference between rigid and fluid? Okay, so before we will give the definition of solid, liquid and gases, we should know the what is the meaning of new term, that is rigid and fluid. So rigid means what? Unbending or inflexible. As you know, a stone is what? Rigid because it is unbending or inflexible. And fluid means what? That material which can flow easily. Okay, and requires a vessel to store it. Fluid. Okay, water, as you know, water is a fluid because if you pour water on the top of table, so it will flow rapidly on the surface of the table. Okay, and therefore water requires what? A container to store it. Milk is what? Yes, milk is a fluid. Chlorine gas is also fluid. Okay, suppose if you gas, if you took in open container, so it will what? It will diffuse immediately in the environment. So keeping this point in mind, we will now define solid, liquid and gases. So as you know, the solid is rigid form of matter. So due to their rigidity, solids have a tendency to maintain their shapes when subjected to outside force. Okay. Now the solid is their rigidity, or we can say here solids does not require a container to keep them. Brick and log of wood are two common solids. Okay, here we can understand basic things. Okay, a liquid is a fluid form of matter which occupies the lower part of container in which it is kept. A liquid does not fill the whole container. Okay, now being a fluid, liquid requires a container to keep them. A liquid as well as a defined surface, so liquid can be kept in open container. Okay, as you know, the liquid has a what? Well defined surface, so liquid can be kept in an open container. The liquid will not escape from the open container by itself. Water and milk are two common liquids around us. Okay, but it will escape, but after some time, it takes some time, then it will escapes in a small amount. Okay, now gas, suppose if you are thinking about gas, so gas is also a fluid form of matter which fills the whole container in which it is kept. Okay, if you pour a liquid in a beaker, so it takes a downward only portion, but gas they are constantly moving throughout that container. Okay, it is a common observation. Okay, requires a container to keep them. A gas does not have a free surface, so gas to be kept in a closed container. If you open this, then whole gas it will diffuse in an environment. Okay, A gas will escape with in open container. See, this is why gas are usually kept in a airtight gas cylinders. For example, cooking gas, as you know, LPG is kept in airtight metal cylinder. Okay, whatever our domestic fuel we are using, okay, butane gas, our cylinders, okay, airtight metal cylinders. Okay, from now these are what here examples we discuss regarding rigidity, fluidity, about solid, liquid, and gases. Okay, now we can classify here solids, liquids, gases in detail. Okay, so these are what regarding your today's lecture. If any doubts, we will discuss in our doubt session. So happy learning, take care and stay safe. Thank you very much.